All right, ladies and gentlemen, we have this video called Tangent Lines and Derivatives. We're going to go over the odd number sections in the video. So, ladies and gentlemen, let's take a look at what they want us to do. They want the equation of the tangent line to the curve. Here's your curve at the indicated point. This is the point P. And remember what we discussed. This is the x coordinate and the y coordinate here. So we have the x coordinate, y coordinate of the one and only point, and you can see that in the graph here. So what we're going to try to do is get the equation of the tangent line at this particular point. And the equation from algebra, first of all, of any linear equation, which is a line, we use point slope form. And in this question, they gave us the point, 1, 4. So x1 is 1, y1 is 4. So x1 is 1, y1 is 4. So you really have y minus 4 equals m x minus 1. So this is the equation of the tangent line. But what we need is the slope of that tangent line. So where the calculus comes in is finding m tangent here. And this is what we discussed in lecture. So this is what we're looking for. The equation of the tangent line, that's L tangent. So we need the slope of the line. Okay, the definition is going to be, again, the derivative of the function evaluated at the x coordinate of 1. So remember, the x coordinate here is 1. And we're going to try to find the slope of that tangent line. So we need the derivative here. So we're going to use this operator notation, and the curve now is 4 minus x plus x to the third power. All right. And let's see what we get. Now, I guess we'll do all the, I guess we'll list the properties here for you guys. Okay. Derivative of a sum is sum of derivatives. Derivative of a difference is difference of derivatives. Excuse me. Derivative of a constant is 0. Derivative of x is 1. The derivative of x to the third power we know is 3x squared here. So m tangent will be -1 plus 3x squared evaluated at x is 1. So you get -1 plus 3 times 1 squared, -1 plus 3, which will be 2. So, ladies and gentlemen, m tangent is 2. Okay. So we have the information we need to continue. We're going to replace this m tangent with the number 2 now. So let's bring this down, or at least copy it. And again, we'll end up with y minus 4 equal to 2 times x minus 1, or distribute here. Okay, solving for y, you're going to end up with the, what do we call that again? Not the point slope, but the slope-intercept form. And this is the equation. This is your L tangent. 2x plus 2. Now, let's illustrate what this means. If I go to Desmos now, I think it's browser on this. Is it browser? Let's see the scene. Okay. Okay. browser. All right. Let's go back here. Nope. So browser now. There we go. I guess it's going to play that kind of game. All right. Let's move this out of our way. At least make it tiny so it's not in the way. Let's get rid of the advertisement. So down here, I might be able to. Can I insert? That's undo. So let's do this y is 2x plus 2. We're going to go all the way down here. Y equals 2x plus 2. And ladies and gentlemen, I like to change that color of that derivative there to red. And let's take a closer look. So you guys can see exactly what's going on, okay? What you're looking at is the derivative of the tangent line at the point 1, 4 for the given curve y is 4 minus x plus x to the third power. And that's what they're looking for. All right, let's go to question number 3, okay? So I'm going to only do the odds here. And in this question, they want the same thing, okay? You're going to, again, use y minus y1 is m tangent x minus the x1. This is the equation of your tangent line for the curve y is x minus 1 over x plus 1 at the location 0, negative 1. So x1, the one and only point you have right here, x1 has the value of 0. We're going to plug that in. Y1 has the value of negative 1. So you're going to end up with y minus the negative 1 is m tangent x minus 0 here. All right, let's do a little bit of simplification, a little bit of arithmetic, algebra, whatever you want to call it. And again, what we need to end up with getting is m tangent again. So let's write down the definition of m tangent. That's the slope of the tangent line. It is that first derivative. Okay. Let's keep it in blue. M tangent is the first derivative evaluated at x equals 0 because that's the location there for x at this particular point. That's the x coordinate. But this time we have a rational function to differentiate, which means we're going to have to use the quotient rule. All right, quotient rule. So since y is x minus 1 over x plus 1, the quotient rule will be take x plus 1, the denominator, and square it. Bring up your denominator and then differentiate the numerator, x minus 1, minus, think of that numerator as a constant. Okay, this is quotient rule, if you guys recall. Quotient rule for derivatives. We have to differentiate now the denominator. So we're looking at quotient rule here. Okay. This derivative is 1. This derivative is 1. So we end up with x plus 1 minus x minus 1 over the x plus 1 squared. X plus 1 minus x plus 1 over x plus 1 squared. So our x's cancel, and we get the derivative going to be 2 over x plus 1 by the quotient rule. Don't forget, we got to evaluate this at x equals 0 because that's what m tangent will be. 2 over 0 plus 1 squared is 2 over 1 squared. ladies and gentlemen, m tangent is actually 2. There we go. There it is, 2. All right, so let's see what we end up with here then. So this is L tangent, the equation of that tangent line. Okay, so here's a whole bunch of homework questions we're going to go over here, and I think I'm only going to do the video of the odds, and the rest I will do, here in the sheet for you guys. Probably, we'll see. So we end up getting 2x minus 1 now. So, ladies and gentlemen, this is the equation of the line tangent to the curve at the indicated point, 2x minus 1. So, again, if I go over to the browser, I'm going to change this equation. All right. Well, I'm going to do a couple of things. Okay. So here is the equation, but I have to change the tangent line. That's going to be minus 1 here. So we got minus 1. And there it is, ladies and gentlemen. You guys can see. Let's get that in right in the middle. That's exactly what they're looking for, okay? The equation of the line, tangent to the curve at that indicated point. Okay. Let's take a look at question number 5 now, okay? So it's the same question, different functions, different points. Use the point slope form as we discussed in class. There's your L tangent. We're trying to find these values now. X is pi here. Okay, we got your X coordinate, your Y coordinate. That's the first and only point. So x1 is pi, y1 is 0. So y minus 0, I guess we'll just try to copy all of this. Okay. I guess we can move it down. Who cares? And let's simplify. Y minus 0 will give us y. And y is m tangent x minus pi now. Okay, the point is here pi 0, where the curve is tangent. And this is defined, ladies and gentlemen, let's point this out, over a restricted domain from 0 to 2 pi. So your domain here goes from 0 to 2 pi. I just want to point that out, okay? Tangent is periodic. There's more, I should say, periods of tangent, but we're just looking at 0 to 2 pi. All right. And the indicated point is at pi 0. So let's find our m tangent again. That definition is the derivative evaluated at x equals pi. So we need the derivative of tangent. Okay. The derivative of tangent is secant squared, and we have to evaluate this if we're going to get m tangent here. So m tangent is going to be secant squared of pi now. So we want to know what this is here, okay? Now, you have to know what secant of pi is. Let me do something here for you guys, just a little bit of algebra or arithmetic or trig here. Secant is actually the reciprocal of cosine. Okay, we're going to square that. This is what M tangent's going to be. So what that means is I do have to know the value of cosine of pi. Let's get a highlighter, I guess. I don't know what color. Cosine of pi. So you're going to have to deduce this, maybe knowing how the cosine curve looks. I talked about this in my trig course today. Cosine of pi is actually -1. So 1 over -1 is +1. +1 squared is 1. So now, ladies and gentlemen, we found M tangent to be simply +1 here. So these questions are pretty simple, by the way. All right, it's 1. And we replace that right up here. So that means y is 1 times x minus pi. And that's going to give us y is simply x minus pi. This is our L tangent here. All right, so I did put it up there so we can see it. Of course, we're going to look at the graph. L tangent x minus pi. So I'm just going to go back here and, all right, I guess I'll show you guys what I'm doing here. We're going to go to the tangent curve. I'm going to get rid of this, keep tangent, look at my point, label it. I got to change my derivative to be x minus pi. And pi is down here. All right, now I'm going to scroll right in so you guys can see. This is what we're looking for, the equation of the line, tangent to the curve at the point pi 0. So we're barely kissing that curve. Pretty nice. And that was question number 5. All right. So we're going to look at question number 7 now. All righty. So, okay, let's go back to the iPad. Here's question 6. We're going to do question 7 here. It's a nice question. The function's y is x sine x at pi over 2, pi over 2. So you got your x coordinate and your y coordinate of the one and only point. You're going to use this point slope form. You need a point and a slope for the L tangent. So the line tangent to the curve at this particular point here. Now, the domain here is not restricted, so I just want to let you guys know that. The x coordinate and the y coordinate are the same, so this will be pi over 2, pi over 2. I'm going to bring all that down. And we really have y minus pi over 2 is m tangent x minus pi over 2 because those 2 points, x1 and y1, are the same. So, ladies and gentlemen, we need m tangent again. M tangent. So, all right. That's the derivative of y evaluated at, let's get rid of this, the value of x being pi over 2. So this is the x coordinate. It happens to be the same as the y coordinate here. This is what they're telling us here, okay? Pi over 2. It's the x coordinate, in case you guys are wondering here. Let's get a highlighter. So pi over 2. Pi over 2. It's the x coordinate. Alrighty. The function y is x secant x. So we're going to have to use the product rule, PR for product rule, when we get our derivative. So y prime will be, let's move it all the way over here. x, the derivative of sine, plus sine, the derivative of x. So, ladies and gentlemen, derivative of sine is actually cosine. The derivative of x is 1. So, y prime is x cosine x plus sine x. We have to evaluate this at pi over 2. Okay? This is going to give us our m tangent. So, plugging in pi over 2 for x, we get cosine now, pi over 2 plus sine pi over 2. So we're going to have to understand what cosine of 90 degrees is, and I believe that was 0. And then sine of 90 degrees, okay, is 1. So your m tangent becomes pi over 2 times 0 plus 1, or m tangent is 1. Okay, ladies and gentlemen, m tangent is 1. So replace this with a 1. Now let's see what this gives us here. Y minus pi over 2 becomes 1 times x minus pi over 2. We're running out of space. I'm going to bring this down. So plug in your m tangent and do a little bit of algebra, meaning 1 times anything will be itself. And notice what's happening. You got that minus pi over 2 on both sides. So if I add a pi over 2 to both sides, it cancels. So that particular line is just x. This is my altangent. This is the equation of the line tangent to the curve. Y is x. There's your answer. All right. So let's try to go back here. Let's remember what this curve was. It's that purple curve, or no, blue curve, x sine x. Okay, and the tangent line at that point is just y is x. So I'm going to go here, and I'm just going to fix this one first. There's my tangent line. I'm going to disable and go to the real function and label it. And as you guys can see, it looks like I have another label. Let's get rid of that label there. Okay. So what I want you guys to see is at that point, y equals x is the tangent line. All right, so we have that curve at that point. The red line is the tangent line at pi over 2. So that was number 7. That brings us up to 9. And question 9 is a different question. 9, ladies and gentlemen, is we're going to try to find the horizontal tangents, horizontal tangent lines. Okay, so when we abbreviate that, and that's to this particular curve right here. Okay. Horizontal tangent lines, let's remember, I abbreviate that HT. That's where your derivative equals 0. Okay, because that's really saying the tangent lines must have a 0 slope if the line is going to be horizontal. So that's the key. This goes back to beginning algebra. Horizontal lines have a 0 slope. So it's a different question. We did talk about that. They want to determine the location. And location, ladies and gentlemen, is code for the x and y coordinate values. That's what a location is. So they want us to find the location, the x and y coordinate values, where we have what's called a horizontal tangent. Now, the procedure is let the first derivative be 0, solve for x. So here's that procedure. And I want to put this in a block because I want it to stand out, because I want you guys to know that this is the process you guys use to find horizontal tangents. So, okay, number 9, location of horizontal tangents. Now, all right, I'm going to have to get the first derivative of this function and set it equal to 0. So I'm going to differentiate this function. So maybe it's helpful to try to differentiate it here. I don't know. Y prime is the derivative of that x cubed minus x squared minus x plus 1 now. So I'm going to take that derivative. And differentiate all the terms. Okay, power rule. 3x squared, 2x, 1, and this derivative is 0. So y prime will be 3x squared minus 2x minus 1. All right, there's your derivative. Set that equal to 0. Remember the process. This is important. So you're going to end up now with this equation here. You have 3x squared minus 2x minus 1 equals 0 here. Okay, so not quite sure what colors to use. You get a highlighter here. This is what y prime is. So set that derivative equal to 0, solve for x. So ladies and gentlemen, you have a quadratic equation here. And you're going to have to remember a little bit of algebra in order to solve that quadratic, right? You're going to solve it by factoring. So I find a lot of times that when you're dealing with a calculus question, not always, and you have a polynomial, it's going to be factorable. Okay? A lot of times they give you some nice, beautiful, and simple curves that all the work here is, it's a nice polynomial. Okay, so we're going to set this derivative equal to 0, which means 3x squared minus 2x minus 1 is 0, because this is what y prime is. Okay. So what you have here, if we go back and show you here, that's your derivative. We have to solve this for x now. So let's remember, we solve for x. And how you do that is by factoring. So we're going to have to factor a quadratic. Now, you get to use your favorite technique to factor. I'm going to use what's called the crisscross method. So we got an a value here, a b value, and a c value. So we need the product AC, which is 3 times negative 1. And that'll give you negative 3. We're going to put that number here. B goes down here. Crisscross method. So we're going to need two numbers multiplied together is negative 3. This is going to be where the product goes. And the sum has to be -2. So the product of two numbers is -3. Well, the sum is -2. We're going to use the crisscross method. So it looks like -3 times 1. We're going to put those numbers right here. And let's double check what that is. -3 times 1 will give us -3. But -3 plus 1 will give you a -2. So there you go. Those are the numbers. So when we factor, we're going to put x here. This is the format. Don't forget, this equals 0. We're focusing here on solving this quadratic here by factoring. Okay. And the numbers that we found, -3 goes here, +1 goes here. But recall from the crisscross method here, the a value is a +3. Right in here, a is 3. So what you have to do is divide both of the numbers that you got by the a value, and in this case it's 3. Now ideally you would like to get a nice integer value, right? And it depends on how you look at the number, but you know, negative, you can look at it as a -3/3 is a -1, and that's an integer, so that's what we're looking for. We like that. We're just going to simplify. And in the case where you can't simplify here, like you get 1/3 and you can't get an integer value, right? 1/3, that's a fraction. All you do is put your 3 in front of this x. So you'll end up here with 3x plus 1, and then that'll equal 0. So, ladies and gentlemen, what you did here is you factored right in here. Okay, so that's factorable. Now you are on your way. We're going to use what's called now here the zero product rule. So if you recall from beginning algebra, the zero product rule. And that's if you multiply two numbers together and it equals 0, then the triangle was 0 or the square was 0. So I want you guys to see this here, zero product rule, and we'll put orange here. Here's the first term. And I guess I'll use brown for the second term. And this is going to equal 0. So the product equals 0 here. So again, that means the first term was 0 or the second term was 0 or even both. Now, that's the zero product rule. On your paper, very often, here's what you do. We do this t. That's just to separate your paper into two places. And we set that x minus 1 equal to 0. We set the 3x plus 1 equal to 0. We're going to solve for x. So here's that first term we're talking about, and it's 0. And here's the second term, and it's 0. So, you know, you're going to add 1 to both sides, and you get x equals 1. Okay, so there's our first solution. And solve for x here. Subtract 1, you get 3x is -1. Divide both sides by 3, and now you get x equal to -1/3. So, ladies and gentlemen, these are the two solutions here. Okay, they're the x values, but remember, we need a corresponding y value. So, although x is 1, we don't know what y is. When x is -1/3, we don't know what y is. So we're going to have to find those values out. All right, just looking for a few things here. Okay, now when x is 1, go back to the original equation. And that's what we're going to look at. We're going to find that location. when x is 1, let's find what y is. So just plug in a 1 for x. And so you get y being 1 cubed minus 1 squared minus 1 plus 1. Order of operation, let's see what this gives us, is 1 minus 1. Okay, minus 1 plus 1. So now we know y is 0 here. All right, so when x is 1, y becomes 0. So x is 1, y is 0. Now let's make sure we see that location here. So this is where the location is, like we said. X is 1, y is 0. That's your first point. That's where you have a horizontal tangent again. Now, remember what I said earlier. That's like standing in a valley here. You know, like if you put a person here, you're in a valley. And let's draw a little person, a stick figure. So you're in a valley over here. That's where you're going to have a horizontal tangent. Now, the other one here, you're on top of a hill. And that happens when x is that negative 1/3 value here. Okay, so remember when we solved this quadratic here, we got x being negative 1/3. So we can put the location here. We've seen it already in 3 places and 3 colors. Here's the first location. We need to find now the y-coordinate value when x is negative 1/3. So the y-coordinate when x is negative 1/3. So I'm going to go over here. And now change your x value to be negative 1/3. So if that's the case, plug this in. We get negative 1/3 cube. I have to write this vertically. Minus negative 1/3 squared minus the negative 1/3 plus 1. We're plugging in the value of x here being negative 1/3 into your equation here. Now, I'm going to do a little bit of cheating here, meaning I'm going to use that TI and get the y value. Okay, so let's go to the TI and get that y value. And we'll plug it in. So I'm going to put in parentheses negative 1/3. We're going to cube it. Minus negative 1/3. And we're going to square that one. Oops. Let's go back. I'm going to cube that. Okay, let's come out. Minus negative 1/3. We're going to square that. Minus the negative 1/3. That'll be plus 1. So, ladies and gentlemen, here's the numerical value. But if I go to math fraction, I'll get 32 over 27. That's the reduced fraction answer. So when x is negative 1/3, y is 32 over 27. So, okay. So this location is what we're talking about. Negative 1/3, 32 over 27. So there you go, ladies and gentlemen. There's the answer. Okay, so I just want to let you guys know this is how we find horizontal tangents here for these particular questions. And that's that for number 9. We're going to check to look at the next question here, okay? All right, number 10, you guys can try. I'm going to do number 11 here, okay? And again, I'm going to point out to you guys, you're at the top of the hill right here. So I can already tell you when you're at the top of a hill and when you're at the bottom of a hill, we're going to see that that's the location of your horizontal tangents, right? So for the tangent line and the line to have a horizontal or the line to be horizontal, that means your slope is 0. So I have to take the derivative of y and I solve for x. That is the deal. Okay, and I'm going to try to take that derivative here since I can see it now. So we'll say y prime will be, I'm going to differentiate the x cubed minus 12x plus 4 now. So by properties of derivatives now, I'll bring it down. Here's what we get. 3x squared, 12, and 0. Okay. So we have 3x squared minus 12. There's our derivative. We're going to set that equal to 0. So if we set y prime equal to 0, you say, what do we get? 3x squared minus 12 is, in fact, 0. And we have to solve for x. Don't forget that part. All right. We're going to do a couple of things with this. We can factor out the 3, the greatest common factor, and we get x squared minus 4 now. Now, if we divide both sides by 3, x squared minus 4 is 0. Okay, now this is special factors. X plus 2, x minus 2 equals 0. I can solve it by using beginning algebra, or I can use the square root formula. Add 4 to both sides. I get x squared is 4. Square root formula. X will be plus or minus the square root of 4. Or x will be plus or minus 2. These are the x coordinate values, plus or minus 2. So, ladies and gentlemen, plus or minus 2 for x. Let me show you guys here. Because we're going to get the y coordinates. This is when x is negative 2. And as you guys can see, this is when x is positive 2. So to get the y coordinates, if I said x is positive 2, now y will be 2 cubed minus 2 times 2 plus 4, or 8 minus 24 plus 4, negative 16 plus 4, y is negative 12. So when x is positive 2, y is negative 12. I guess I can put that in red. And sure enough, that's kind of what it looks like. X is positive 2, y is negative 12. This is the location. Okay, we found the x and y coordinates. That's the location. That's what they want. Now, when x is negative 2, y is 20. So, let's get rid of that. Negative 2 cubed minus 12 times negative 2 plus 4. Y is negative 8 plus 24 plus 4, or we say y is 20. So when x is negative 2, y is 20. This is the location, and sure enough, that does look exactly like the coordinates on the curve. So when you have a horizontal tangent, the slope is 0, okay? M tangent is 0. So take that first derivative and solve for x. These are the locations, and that's what they want, the coordinates. All right, number 11, good. Okay, number 12 is going to be interesting, but we're doing the odds. And I may do the evens, write that down and, upload it one day, but I'm at least going to give you these guys here. So we're going to find horizontal tangents, ladies and gentlemen. Y is sine plus cosine over a restricted domain. Now, looking at the picture again, if I said to you, I know these are not polynomials, but they're very similar. They're kind of beautiful and nice like them. So you're at the top of a hill. Remember what we were noticing here, that pretty much you can find a horizontal tangent line when you're at the top of a hill or in a valley. So I can actually look at these pictures and I can know that, you know what? These are where the horizontal tangent lines are. Now, on a test, don't just do this. Some people do. You do the analysis, meaning if you have a horizontal tangent again, let's write that down. The slope of the tangent line is 0. That's what happens with every horizontal line. That means that first derivative equals 0, and we solve for x. So take the derivative of the function, and what you do is solve for x. Okay. So I'm going to try to do it over here and bring it down like I've been doing. So now we have the derivative of sine plus cosine. And that's over the restricted domain from 0 to 2 pi. So let's get this derivative here. Okay. And I guess I'm going to move it down. Okay. So using properties of derivatives, y prime is going to be the derivative of sine plus the derivative of cosine. So the derivative of sine, by the way, is in fact what? Cosine. And the derivative of cosine is minus sine. So my derivative is cosine minus sine. Now, I have to set that equal to 0, and then I solve for x. So we have cosine minus sine and 0, a very famous trig equation to solve. Okay, this is really a trig equation. And that means cosine equals sine if I add sine to both sides. And if I divide both sides by cosine, on the left I get 1, on the right I get tangent. So we have tangent x is the value 1. And this is over 0 to 2 pi now, a restricted domain here. So they gave us a restricted domain. That's an important detail. So tangent is 1, and what I have to do personally is I want to go back to trig. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, we're going to say all students take calculus. What this means is the tangent curve is positive in quadrants 1 and quadrant 2, because that's kind of what that means. That's the being greater than 0, positive. So let me do this. You have a ray, quadrant 1. And this is your reference quadrant, by the way. And I usually in trig, if you look at my trig videos, There's my reference quadrant. What I do is I say, hey, even though, we have to get the reference angle is 1 over 1. We go back to some geometry and trig. Here's that reference angle, 1, 1, square root of 2, and students say, hey, that's pi over 4, 45 degrees. We're going to have to use radians. Okay, so giving you a little trig review. So my first solution, by the way, is pi over 4, because in quadrant 1, the angle is the reference angle. So I got two solutions. This is a quadrant 1 solution, value of x. Okay. And I know I didn't do this earlier, but let me remind people here, when I got these solutions, those are two solutions. So x is positive 2, x is negative 2. I apologize if I went a little too fast, because that's what this means, plus or minus 2. All right. Okay. So, ladies and gentlemen, there's one solution. There's another solution, because tangent's positive in the opposite quadrant. So you have to add a half a circle. Pi radians is what you add. So the second solution is going to be pi over 4 plus pi radians. And so let's add a fraction with a whole number. And so you get 5 pi over 4. So here's my second solution here. Pi over 4, 5 pi over 4. So when I go to the picture over here, you might say, well, is this where, and it is. Let's see if I can see it. This is where pi over 4 would be. That's the x coordinate. So if we want the y coordinate, remember, I don't think it's big enough, but I'm going to try to squeeze it in. So if x is pi over 4, get the y coordinate by plugging the value in. Y is sine pi over 4 plus cosine pi over 4. Now, you guys should know that this is the square root of 2 over 2 plus the square root of 2 over 2. Y is simply the square root of 2. So the location, x is pi over 4, y is square root of 2. This is our location here. There it is. Okay. 5 pi over 4. All right. Okay. So over here, it's a little bit smaller, but this is where 5 pi over 4. It's smaller than 4, a little bit, but it looks like it's 4. Let's find out what's the y coordinate value now. So I'm going to erase my work. You guys can go back and take a look. Okay, so let's kind of deduce this here. Just a little bit of trig. Sine pi over 4 plus cosine pi over 4. Okay, let's find that. Well, what is sine? It's sine 5 over 4. Sine, let's go back to the quadrant. Sorry. Quadrant 3, this is where the pi over 4 angle is. So I want you guys to remember, this is 5 pi over 4 now. Tangent's positive, but both sine and cosine are negative. You say, so what does that mean? Well, this is what it means. Negative square root of 2 over 2 plus a negative square root of 2 over 2. Y will be negative square root of 2 over 2. So the x-coordinate value of this location is 5 power over 4, but the y-coordinate is negative square root of 2. Okay? Because sine and cosine are both negative in quadrant 3. So if the angle is 5 pi over 4, they're both negative, and that's how we deduce those locations. So we found the locations here, ladies and gentlemen, where you have horizontal tangents. And so, that means you do have to recall a little bit of some trig algebra, not a lot. And I think I'm going to double check question. I'm going to call it let me see, do I have 15 here? Oh, this is a good one. Let's try 15. I don't know how many I have. What does it say? This is a different question. Determine the point on the curve x and y coordinates where the slope of the tangent line is equal to 10. Slope, let me put that in red. Slope of my tangent line is equal to 10. Okay, find the location where m tangent equals 10. So take a look at that, ladies and gentlemen. That's exactly what they're saying. Slope of the tangent line is equal to 10. All right. Now, you say, what is m tangent? Well, that's the derivative. Now, we don't know the point because that's what they're asking for. So we're going to have to set this derivative equal to 10. So let's differentiate the function y, and it has to equal 10. That's what they're saying. Find the location, the value of x and y, where the slope of the tangent line equals 10. So, like I told you guys, memorize this derivative. Shows up a lot. And then I get a proportion. So I'm going to cross multiply. Got to solve for x. So we get, ladies and gentlemen, on the left, 1 equals 2 square root of x times 10, 20 square root of x. Square root of x is 1 over 20. So that means x will be 1 over 20 to the second power here. Okay? That's the x coordinate. 1 over 20 to the second power. Is that what that is? All right. Okay. I could do the arithmetic, but I guess that's 1 over 400, right? Anyway, let's keep it as 1 over 400. So this is the x coordinate. What is the y coordinate? Okay, because they want the point, and the point is an x and y coordinate value. So y is the square root of x. So I have to take the square root of 1 over 400. By properties of radicals or square roots, it's 1 over 20, I guess. It's a y coordinate. Yeah, I guess so. So here's the point. Literally, it's a point on the curve. 1 over 400, 1 over 20. That's the x and y coordinate values for this point here. All right. so that's kind of very small in some ways there. If I try to, I'm not even going to put it in Desmos. You just probably see it at the origin here. You know, the location is really close right here. You know. Anyway, that's number 15. All right, let's see number 16 is probably similar. 17. What is 17? Yeah, I got to double check 17, by the way. Anyway, I think we're going to stop right here. I'll double check 17, tomorrow to see if there's a typo. And then I'll do it if there isn't. Okay, and I'll update this video here. So, ladies and gentlemen, I hope you enjoyed these examples. Take care, stay safe, have a wonderful day.